Hey everyone, welcome to The Explainer. So glad you're here. Today we're getting into the technical mechanics of corporate network security, and don't worry, we're going to do this without getting completely bogged down in dry, boring jargon. If you've ever wondered how massive enterprises actually lock down their most critical infrastructure, well, you're in exactly the right spot. We're looking at the core of how networks identify, restrict, and track literally every single person who touches them. So get ready, because we're about to make some highly technical concepts crystal clear and, honestly, a lot of fun to learn. Okay, let's dive into this. I want you to picture a total chaotic nightmare scenario for just a second. Imagine a bustling corporate network operations center. You've got a team of, say, 50 network engineers. Now imagine that to access the core enterprise routers, every single one of those 50 engineers uses the exact same enable password, and that password is just Cisco. Sounds totally absurd, right? But think about it. If a massive outage happens or a critical config gets wiped out at 3 a.m., how on earth do you figure out who actually did it? You can't. When everyone shares a single key to the kingdom, accountability completely vanishes. To solve that exact nightmare, here's our roadmap for today's explainer. First, we'll hit the shared password problem. Second, we'll introduce our core framework, which is the 3 pillars of AAA. And third, we're going to compare RADIUS versus TACACS+.
All right, kicking things off with Section 1, the shared password problem.
So we just established that a single shared password fails spectacularly at corporate scale, right? I mean, if an employee leaves the company on bad terms, you definitely don't want to go in and manually change the shared password on 500 different routers. There's this desperate critical need to know exactly who logged in and exactly what they did. And this brilliantly illustrates the solution. We've got local AA on one hand, where the router checks your credentials against a tiny database stored right on its own local NVRAM memory. Now, for a tiny office with one router, hey, that might be fine. But for large companies, it's totally unscalable. Then, on the flip side, we have server-based AA. This is where the magic happens. Instead of storing passwords locally, the router forwards the user's credentials to a dedicated centralized AAA server, something like Cisco ISE. You update an engineer's access in one single place, and boom, that change instantly applies across thousands of devices. Moving right along to Section 2, the 3 pillars of AAA. To really grasp this highly technical framework, I want you to think about a physical security checkpoint at, say, an exclusive VIP event. You don't just walk in and do whatever you want, right? There's a very specific, strict sequence of events that happens at the door to keep the venue secure. Well, network security works exactly the same way. The hero of our explainer today is the AAA framework, and right up front, I really want to clear up a massive misconception. AAA is not a single protocol. It's not just one simple piece of software you flip on. AAA is a sequential security architecture broken down into authentication, authorization, and accounting. Basically, it's a philosophy of access control that forces a device to answer 3 distinct questions about anyone trying to use it. Here's that sequential 1, 2, 3 process broken down. Step 1 is authentication, answering the question, who are you? Step 2 is authorization, answering, what are you allowed to do? And Step 3 is accounting, answering, what did you do? Think back to our VIP event analogy for a second. Authentication, that's the bouncer checking your ID at the door to make absolutely sure you are who you say you are. Authorization is the bouncer looking at a list and giving you a specific VIP wristband that lets you into the lounge, but, maybe not backstage. And accounting? That's the security cameras keeping a literal receipt of every single place you went and everything you did while you were inside. So let's see how this actually builds out in a real network environment, starting with authentication. When a network engineer attempts to log into a router, maybe remotely via SSH or directly through a console cable, an invisible handshake begins. The router immediately stops them in their tracks and challenges them for their credentials. This is essentially the device demanding that the user proves their identity before anything else can possibly happen. You are just not getting through that front door until the router knows exactly who you are. Now, what's really interesting about this slide is how authorization surgically dictates what happens next. Once your identity is verified, the system assigns you a privilege level. Take a look at the examples. A junior engineer might be given privilege level 1. What that means is they're only authorized to use basic show commands to look at how the network is running, but they can't actually change anything. A senior engineer, however, gets privilege level 15. They're authorized to enter global configuration mode and make sweeping changes. This surgical restriction is absolutely brilliant because it actively prevents a junior tech from accidentally typing the wrong command and totally wiping out the entire network configuration. And finally, we hit the third pillar, accounting. This is the ultimate auditing phase.
Even if you're a senior engineer rocking privilege level 15, you are not operating in the shadows. The router tracks every single command you type. It tracks exactly how long you were logged in and how much data was transferred. It generates an itemized receipt of your entire session and sends it right back to the AAA server. This ensures total, undeniable accountability. If the network goes down at 3 a.m., those accounting logs are going to tell you exactly whose account was used and the precise command they typed to cause the outage.
All right, bringing us to Section 3, RADIUS versus TACACS+.
So we understand the AAA framework conceptually, but how do the routers actually talk to those centralized servers to make this happen? Well, understanding the technical mechanics of these two server-based protocols is absolutely crucial for CCNA candidates and working network pros alike. Here we have the two heavyweights of network access. First, RADIUS, which stands for Remote Authentication Dial-In User Service. Despite its old-school dial-up origins, RADIUS is incredibly popular today, particularly for network access like enterprise Wi-Fi using the 802.1x standard. Then we have TACACS+, or Terminal Access Controller Access Control System Plus. TACACS+ is the modern gold standard for device administration, meaning it's the protocol you use when engineers are logging directly into routers and switches to manage them.
I really want you to pay close attention here, because this comparison is an absolute exam prep goldmine. Let's walk through these stark technical differences side by side. First up, the standard. RADIUS is an open IITF standard, meaning it works universally across all vendors out of the box. TACACS+ is Cisco proprietary, though honestly it's been widely adopted by a bunch of other vendors over the years. Next, let's talk about the transport protocol. RADIUS uses UDP, specifically ports 1812 and 1813, or the legacy ports 1645 and 1646. TACACS+ uses TCP over port 49, which makes it a much more reliable connection-oriented protocol. Now look at encryption. This one is huge. RADIUS only encrypts the password inside the packet. The username and all those other details just fly across the network in plain text. TACACS+, on the other hand, encrypts the entire payload of the packet. Username, password, attributes, the whole shebang is locked down.
But the biggest difference really lies in their architecture. So the crucial point is how they handle those AAA steps we talked about. RADIUS actually combines authentication and authorization into a single, mashed-together process. Once you're authenticated via RADIUS, you can't authorize that person differently later on. TACACS+, however, strictly separates authentication, authorization, and accounting into entirely independent processes. Why does this matter? Because with TACACS+, you can authenticate a user once, but then run a brand new authorization check for every single command they try to type on the command line. It literally gives you unparalleled, granular control over device administration.
Which brings us to our final thought for this explainer. Look at your own infrastructure, or maybe the networks you're studying to build. You now know the absolute nightmare of the shared password, you understand those vital 3 pillars of AAA, and you've seen the deep underlying technical differences between RADIUS and TACACS+. So I leave you with this question. Based on the granular control and payload encryption we just discussed, which protocol are you trusting to secure the core of your enterprise network? Think carefully about those architectural differences, because the security of your entire network depends on the answer. Thank you so much for learning with me today, and definitely keep exploring these incredible protocols.